The question seems simple, almost child's play. Which came first, the chicken or the egg? Yet this isn't just a circular riddle, it probes the very nature of origin and causality. Scientifically speaking, the answer hinges on a crucial biological detail. The modern domestic chicken, Gallus domesticus, possesses unique genetic traits not found in its ancestors. These traits had to arise from a mutation. That specific mutation, the one defining the first true chicken, necessarily occurred within the reproductive process, either in the formation of the zygote or the fertilized egg itself. Therefore, a bird that was genetically almost a chicken, a proto-chicken, laid an egg. Inside that egg, the mutation finalized. When it hatched, the creature that emerged was the first bird we would classify as a true chicken. So, in a strictly biological sense, the egg containing the first chicken DNA predated the first chicken. But philosophy offers a different lens. Long before genetics, ancient thinkers wrestled with this paradox. Aristotle, in the 4th century BCE, approached it through his concepts of potentiality and actuality. He argued that a fully actualized chicken is necessary to produce an egg, which holds the potentiality of a chicken. From his perspective, assuming the species was eternal and cyclical, the actual chicken must logically precede the potentiality contained within the egg. He essentially believed neither came first in an absolute sense, viewing species as part of an eternal, cyclical reality with no specific starting point. Later, Plutarch, writing in the 1st century CE, dedicated an entire symposium discussion whether the hen or the egg came first, exploring arguments ranging from the nature of creation to logical proofs, demonstrating the riddle's enduring power to provoke thought about origins and the nature of existence itself, separate from empirical evidence. Beyond logic and science, the riddle resonates deeply on a spiritual and symbolic level. Many creation myths implicitly address this paradox. Does life spring forth fully formed, or does it emerge from a seed, a cosmic egg, a period of gestation? The egg, across numerous cultures, symbolizes potential, rebirth, hidden beginnings, and the universe itself. Consider the Orphic egg in Greek mythology, or the Hiranyagarbha, golden womb or golden egg, in Hindu cosmology, representing the source of all creation. The paradox forces us to confront questions about first causes. Was there a divine spark, a prime mover that initiated the cycle? Or is existence inherently self-generating, cyclical, with no true beginning or end? The chicken and egg become metaphors for the mystery of emergence itself. How does complex life arise from simpler components, and where does the initial blueprint originate? Let's pivot sharply back to biology, focusing on a specific molecular discovery that adds a compelling layer. Researchers identified a protein named Ovoclidin 17, or OC17. This protein is absolutely critical for the formation of the hard outer shell of a chicken egg. It acts as a catalyst, speeding up the development of the calcium carbonate crystals that make up the shell. Without OC17, the shell structure as we know it cannot form properly. Here's the crucial point. OC17 is produced exclusively within the ovaries of the hen. This means a hen, possessing the genetic machinery to synthesize OC17, must exist before a standard hard-shelled chicken egg can be fully formed and laid. While the genetic material for the first chicken was inside an egg from a proto-chicken, the specific shell structure dependent on OC17 could only be produced after a hen capable of making that protein existed. This brings us to the synthesis. Evolution doesn't typically happen in giant leaps, but through accumulated changes. The bird that laid the first chicken egg was likely indistinguishable to the casual observer from its own parents. It belonged to a species very closely related to the modern chicken, carrying almost all the necessary genetic information. The key mutation, or set of mutations that definitively crossed the threshold into chickenness, occurred during the formation of the egg it laid. This aligns with the concept of punctuated equilibrium in some evolutionary models, where long periods of stasis are punctuated by relatively rapid bursts of change. often linked to speciation events. The eggshell protein factor OC17 adds complexity. Perhaps the very first genetic chickens hatching from proto-chicken eggs initially laid eggs with slightly different shells, and the OC17 mechanism perfected later, becoming standard once the hen population was established. Evolutionarily, the genetic definition points to the egg first, while the specific shell, biochemistry, points to the hen first for that specific shell type. So, has the riddle been cracked? From a purely evolutionary genetic standpoint, the egg laid by a proto-chicken containing the first true chicken zygote came first. However, considering the specific biochemistry of the modern eggshell, OC17, the hen capable of producing that protein had to exist before that specific type of egg could be formed. Ultimately, the scientific consensus favors the egg, as the genetic identity defines the organism. Yet, the riddle's enduring power lies not just in a literal biological answer, but in its philosophical weight. It forces us to consider the nature of origins, causality, potential versus actual, and the very definition of first. It reminds us that sometimes the most profound questions are those that bridge scientific understanding with deeper, more ancient modes of inquiry. What other paradoxes challenge our understanding by forcing science and philosophy into conversation?